explore solving an inequality using a graph. Let's start with the graph of a function. And let's see what the graph can tell us about the solution set of the inequality f of x greater than 0. And also about the solution set to the inequality f of x less than 0. Let's think about how these inequalities relate to the graph. So we see that the points on the graph above the x-axis, the points where the y-coordinate is greater than 0, correspond to the solutions to the inequality f of x greater than 0. Right? So for these points, the y-coordinate, which is f of x, is positive. What about f of x less than 0? Well, the solutions to that inequality correspond to the points on the graph that are below the x-axis. And for completeness, the points on the graph that are on the x-axis correspond to the solutions to f of x equals 0. So let's draw the x-axis again down here. And suppose we've been given the x-coordinates of these x-intercepts. Minus 8, minus 3, 1, 3, and 7. So for what values of x is f of x positive? Well, we see that on this interval of x values, negative infinity to negative 8, f of x is positive. Now, don't confuse this concept of a function being positive with a function being increasing. You see here that the function is positive, while at the same time, the function is decreasing. The graph goes down here. Right, this part is such that the graph is falling, but we're not asking whether it's an increasing or decreasing function, but whether it's positive or negative. So there it's positive, and it was positive right here on this open interval of x values, and right here, and right here as well. We saw that it was negative right here, and right here. This is x equals 1. So it's greater than 0 on red. You can get an interval notation. Here. It's less than 0 on -8 to -3 union 1 to 3. Now what if we were to ask for the solution set to f of x greater than or equal to 0? So we just include, in addition to what we already have, any endpoints that are also give us x-intercepts. So here it's -8 we include, -3, 1 we both include, we include 3 and 7. And you see that right here, this can be written more succinctly as (3 to positive infinity). And finally, the solution set to f of x less than or equal to 0 is this. All of those 4 endpoints are numbers where f of x equals 0. Let's do another example. So this is the graph of y equals f of x. And for each of the inequalities here, we want to use the graph to determine the solution set. Let's draw in red the points on the graph that correspond to f of x greater than 0. So these are the points on the graph that are above the x-axis. This part right here. Put an open circle right here, because right here corresponds to where f of x equals 0. We want f of x greater than 0. So here to here, another open circle. And finally, this part of the graph over here corresponds to f of x greater than 0. And let's draw in blue the points on the graph that correspond to f of x less than 0. So let's draw the number line. Think of it as the x-axis here. And we see that the function is positive from x equals from negative infinity up to but not including -4. Then the function is negative. On on negative 4 to negative 3. It's positive on negative 3 to 3. On 3 to 4, it's negative. And on 4 to infinity, it's positive. So for this first inequality over here, f of x greater than 0, you have the solution set negative infinity to negative 4 union this interval and that interval. We just look at a number line over here and find the intervals that correspond to f of x greater than 0. And for f of x less than 0, we had the two intervals right here. So now if we want to do f of x greater than or equal to 0, we include any endpoints at which f of x equals 0. So let's see, so f of minus 4, that actually does not exist. F of minus 3 did equal 0. F of 3 equaled 0. And f of positive 4 does not exist. So for f of x greater than or equal to 0, we do negative infinity to negative 4. Negative 4 stays open. It's not in the domain. We do include negative 3 and 3. And we still exclude positive 4. Here, for f of x less than or equal to 0, we had negative 4 to negative 3. We still don't include negative 4. Negative 4 does not correspond to an x-intercept. Negative 3 did, though, so we include that. Include 3, but exclude still 4.